Hi students, as I told you, I'm making this video now in preparation for our mid-unit geometry test over understanding how to find area of rectangles, parallelograms, and triangles. So this test is going to be reviewing for our test on Monday, and that will be October 6th. Monday, October 6th. So I hope that you have a chance to watch this. Okay, we went over number 1 in class, so I don't feel like we need to go over number 1 per se, but I will give you the answer. The answer to number 1 is B, 24. We also in class went over number 2, so that answer is 3, but you should all have that answer. Number 3, the answer is D, 46. We went over that in class. Number 4, the answer is is 17. That we did that one in class. The answer to number 5 is B, 78. We did that one in class. The answer to number 6 is 108 yards squared. We also did that one in class. The answer to number 7 is 84. We did that one in class. And then I believe it's about around number 8 with most classes that we did not finish. So that's the one I'm going to jump in and show you from the beginning to the end how to do. So this question says, find the area of the arrow. So never ever in class have I said, boys and girls, this is the formula to find the area of an arrow. So we have to use our big brains to think about how we can decompose this into familiar shapes that we do have a formula for. So my first thought is that we would decompose it right here. And then that leaves me with a rectangle and a triangle. So I can use the measurements that I'm given to find the area of this rectangle. So if I want to find the area of the rectangle, this rectangle right here that I'm outlining, I can see that it is 10. I know that because it tells me right here that it's 10. 10, and then of course that's the length, and the width is already shown. So if I use length times width equals area of a rectangle, I'm going to do 10 times 4 equals 40, and that's units squared. So I've already done part of it. So now I need to jump in and do the I was just checking to make sure this was recording. Now I need to jump in and do the triangle. Okay, so I'm going to change colors. So when I look at this triangle, I feel like it's tipped up, but I really want to use this as the height measurement. Okay, just like that. And it doesn't have a measurement there, but I know that it's connected to this, which is 8. So that's 8 as well. And then I have to be a little math detective when I find the height. So my height is a perpendicular line right here to the opposing vertex, and so I have to get creative. And to do that, I'm going to look up here to this 12. So if I think about like the height measurement is about from here to here, and I know that the entire height measurement is 12, but I know that this part of it right here is 10. And if the whole thing is 12, then this part must be 2. And if that part is 2, then this part must be 2 as well, okay? So now I can use base times height divided by 2, and that equals, the base is 8 times the height is 2 divided by 2. So that's going to be 16 divided by 2, and we know that that's 8. So this is 8 units squared, and together that would be 40 plus 8 would be 48 units squared. So the answer is 48 units squared. Moving right on to the next one. I told you in class that this one was probably the most challenging, so I'm going to go ahead and read it. It says, Jorge was asked to find the area of this trapezoid. We do not have a formula to find area of a trapezoid. But for Jorge, he forgot the formula, so he cut it into a square, which is a square right here, He cut it into a square, and 2 congruent triangles. And remember, the word congruent is a fancy word for the word same, okay? 2 congruent triangles. So we know that the triangles on either side of that square are the same. So there's one important thing here that I need to remember in doing this. I have to remember that if this is a square, and I know that from here to here is 5, that also means here to here is 5. So if this is 5 and this is a true square, then the length of every side of the square is the same. So that's 5 and that's 5 and this is 5. So if from here to here is 5, but the whole thing is 13, right? Then that leaves me, if I do 13 minus 5, what does that leave me with? What does that leave me with? Think about that. What does that leave me with? Think about it. It leaves me with 8 left over, okay? So if I have 8 left over, then the biggest thing you need to think about here is that I need to share that 8 equally between the rest because these are congruent. So I have to take 8 and divide it into 2 parts, and we know that's 4. So that means this is 4 and this is 4, and that really helps. So to find the area of the square, I'm going back to the square. I'm going to use length times width equals area of a rectangle because squares are rectangles. So I'm going to do 5 times 5, and that equals 25, and that's going to be inches squared. So this is 25. So now, one of the other things that I can do when I think about doing this that's the easiest is I'm going to, in my head, I think it's easiest to take this triangle and move it over here. Okay, if I move it over there, then I get myself a pretty good rectangle, and I know that it's going to be 4 by 5 because that's what its height is. So we know this is going to be 20 inches squared because length times width equals area. So essentially I have a 25 area space and a 20 area space, which is going to give me 45 inches squared. So it would be 45 inches squared. Okay, that's the answer. All right, let's do this. We did this one. A lot of us did this one as class, but I'll go over it again. I'm moving fast because I know you want me to make this as short as possible. Jonah wants to find the area of the parking lot near the baseball field. The parking lot is in the shape of a right trapezoid. We don't have a formula for a right trapezoid, so we have to decompose it. And we need to find the total area. So the best thing to do is to decompose it right here. Okay, so if I decompose it right here, I have a very clear rectangle and triangle. The very clear rectangle and triangle are length times width, length times width. So if I use length times width equals area of a rectangle, I'm going to do 15 times 18 equals 270. So that's going to be yards squared. Okay, yards squared. And then that part's pretty easy, but it's when I get into this triangle, I'll switch to blue. I'm going to want to use this as the base. And a lot of kids are looking at that going, oh, Miss Preen, it's 25. No, it's not. Because we know from here to here is 15 because we stole that from up here. So then if the whole thing is 25 and I take away 15, that's going to leave me with 10 yards. So I know this is actually 10 yards, and that's really important. So this is a right triangle, and so if I'm going to use the formula base times height divided by 2 to find the area of the little triangle on the right there, then I know the base is 10 and I need to find a height measurement. And this is a really good height measurement, but it doesn't have a measurement there. Well, I'm going to have to borrow it or steal it from here because I know those are both the same. So it's 18. So if I do 10 times 18 divided by 2, that's going to be 180 divided by 2, which is 90. Okay, so this triangle is 90. and I'm going to add 270 plus 90 because we had 270 originally and now 90, and that's going to give me 360, okay? And that's yards squared, okay? So that's 360 yards squared. Moving on to the next one. This one is really easy. In class, we talked about how sometimes on these tests that we take, shapes are going to be referred to by their vertex. So we're here talking about what is the area of triangle QRS. So Q starts here, it's QRS. So that's the triangle we're looking for right here. So I know that this is a triangle. This is a triangle. And it's base times height divided by 2, and base times height divided by 2. If I look at the base, I have a perfect base built in right here. This is the perfect base right here. So base is 6 times height. I want to use this as my height, but there's no measurement there. But look, I have a measurement right here, and it's the same. Okay, so base times height is 5. So this is 5 divided by 2. So 6 times 5 is 30 divided by 2, and that is 15. Okay, so it's going to be 15 square inches is our answer. Okay, so give me 1 second. Can you leave that with me? I'm making a video for my class that I have to post, and it's recording right now. So
that's fine. I told him I just sent home with him.
Okay.
I told him I'd send him Jesus online. So.
Okay, perfect. Thank you. All right, I'm back. Okay, so number 12 is in the figure shown below, all the corners form right angles. We know this. Okay, so what is the area of this figure? So once again, here are the announcements. So once again, we're going to have to take this and decompose it right there. Here they come again.
Just a quick announcement, students. Angel Wings is canceled for today. Angel Wings is canceled for today, and it will be rescheduled. Thank you.
Okay, so let's first find the area of this lovely little rectangle here, which we know we're going to use length times width equals area. And so the length is 5 times the width is 7, and that's 35 feet squared. There's no dividing by 2 because this is a rectangle. So we know this is 35. And now we have to get really creative again because we know this whole thing, I'm going to do it in blue, this whole thing right here is 17. And we know from here to here is 5. And if we want to find the area of the larger rectangle, we only want from here to here, right? We only want from there to there. So if we have 17, we're going to take away 5. That leaves 12, doesn't it? 12, 13, 14, 15, 16, 17. So we know that this is actually 12. So then we're going to use length times width again. So the length is 12 times the width is 15. And if we do that, it's 15 times 12, and that's going to be 180. Okay, and that's feet squared. I'm still not done because that's 180 feet squared. So if I take 180 and I add the 35, then I have 5, 11, and it's going to be 215 feet squared. 215 feet squared. So there's our answer right there. Going on to number 13. Ooh, this one's easy too, but it is about a party banner. The owners of Party Palace want to place the company logo on a banner. They need to find the area of the logo shown below to make sure it fits onto the banner. Okay, make sure it fits onto the banner. So what is the area of the logo? So the logo is really like, it's a triangle. So we have a formula for that. And we're given the base measurement, which is right here. And we're given the height measurement, which is right here. It's actually located out here, but that's on the same plane. So if we use the formula, base times height divided by 2, and we plug in the base, which is 14, times the height, which is 16, okay? Excuse me. So if we do 14 times 16, that's going to give us, divided by 2, that's going to give us 224 divided by 2. So if we divide that by 2, that's going to give us 112 inches squared. So that's it, folks. And I do divide by 2 because this is a triangle. All right, let's move on to number 14. 14 can be a little bit challenging, but the first thing I notice about Miss Hanover is that she drew a regular hexagon shown below on the board and asked the class to find the area of the hexagon. So we're trying to find the area of the whole thing, but we're given some measurements that give us the ability to find the area of this triangle right here, okay? Because what I know about a hexagon is that all the sides are the same length. All these sides are the same length. So if that side is 6 right here, then this side is 6, and this side is 6, and this side is 6, and that one's 6, and this one's 6 too. So all of them are 6. So if I want to find the area of that triangle, I've given a height measurement. Look, it's right here. I'm given the height measurement. It's right here. It's right here. So I'm going to use base times height divided by 2. And when I do that, it's going to be the base is 6, and I'm going to multiply that by 5.2 divided by 2. So if I use my calculator, okay, there's the bell. It's going to get a little loud. You're fine. Okay, so 6 times 5.2 equals 31.2. So I have 31.2 divided by 2. So if I divide that by 2, it's 15.6. So I know that this is 15.6. So next, I'm not done. See, they give you the answer right there, but that's only of one. It says, what's the area, of the total hexagon? So I know how many little triangles make up this hexagon. Let's count them. We have 1 here, and 2, and 3, and 4, and 5, and 6. And that makes sense because it's a hexagon. Hexa means 6. So if I take 15.6 and I multiply it by all the hexagons that I have, so if I take 15.6, the area of one of the little triangles, and I multiply it by all of them, it's going to give me 93.6, and that's centimeters squared. So our real answer is this one right here, okay? All right, so now we're going to look at number 15. Triangle QRS has a base of 16 units and a height of 32 units. What is the area of that triangle? What is the area of triangle RTS? So we know that triangle QRS, this big one right here, it has a base of 16 and a height of 32. Okay, just like that. But what would the area of triangle RTS be? What would that be? I'm gonna erase what I did so I can really take a look at it. Okay. I want to know what this one is. Okay. I want just that one. Well, thankfully, I know that if I do red, from here to here is 10, and this whole thing is 16. So essentially, 10 plus what equals 16? Because I got to figure out what goes right there, because that's going to be my base, isn't it? That's going to be my base. Well, I know that if I have to multiply it by 6, so this part is 6, okay? So yay, now I have a height measurement. And I really wish I could put my height measurement right here, okay? I would love it if I could do it. I know that's not perfect, okay? Because then that would show me I have a perpendicular line from the base to the opposing side. But it's okay because look, there's one right here. There's already one here. And we know that it doesn't have to be inside the triangle, okay? It can be anywhere. And we know that it's 32. So if I take 6, this is a triangle, so it's base times height divided by 2. So base times height divided by 2 is going to be 6 times
Last
32.
call for buses. Last call for buses.
So if I do 6 times 32 divided by 2, because it's a triangle, I have 192 divided by 2. So I still have to divide that by 2, and that's going to give me 96, and it's 96 units squared. Okay, so that's going to be units squared. So it's right here. So that was important. remember, you have to know how to identify triangles that they're talking about and make sure that you identify the triangle that they want the area for. All right, we're going on to 16. I know I'm moving fast, but I want to make this video as short as possible. All right, it says find the area of the shaded region. So I know I need to try to find the area of this guy right here, and I need to find the area of this guy right here, okay? And there's a couple ways that you can do this, a couple of ways. So I'm gonna choose to see if I can be a little math detective and figure out what the lengths are, okay? To be able to, I'm gonna try to figure out what the length and width is of this. So I know that I'm trying to find this area, because that's my length. Well, I can steal it from right here at 6. So I know this is 6. And now I need to figure out what this is right here. Well, if I know the whole thing is 8, okay, and I know that it's 6 from here to here, then I know that it's 6 from here to here, and the whole thing is 8, so then this must be 2, okay, because we know that 6 plus 2 equals 8. So I know that's 2. So now that's perfect. I can use length times width equals area of a rectangle. The length is 6 times the width is 2, and that gives me 12. And I'm not dividing by 2 because this is 12 units squared, okay? That's 12. And then I'm going to do the same thing for this one right here, okay? I'm choosing, I know this is 6. Okay, that's 6, and I know if this whole thing is 8, like it tells me right there, and from here to here is 6, then it's the whole thing is 8 here, that's 2, okay? So that means this is 2. So I'm gonna do 6 times 2 equals 12 units squared again, and that's 24 units squared, okay? 24 units squared. So the answer is A. All right, number 17. Daniel folded back the edges of his paper to start making a paper airplane, okay? All right, so what is the area of the shaded region of the paper airplane? Well, this one, I see right away that I have a very, very nice square rectangle here. So I'm gonna see if I can figure out what its length and width is. So the length times the width is going to be the area. So I have a length right here, which is 8. Okay, that's 8. And then my width is a little trickier because I only know what from here to here is. Okay, so but I only want until here. But I know that this is 4. So if this is 4, then this must be 4 too. Okay, so if the whole thing is 10 and this part right here is 4, what must this be? Okay, what must the rest be? Well, it's got to be 6 because we know that 4 plus 6 equals 10. So that's 6. So if I do length, which is 8, times width, which is 6, that gives me 48 inches squared. So that's that part. And then on the top, I still have to figure out this triangle here on the top. My first thought is to take this part right here and swing it over and put it right there. Okay, so it's no longer here anymore. And then I have a true square, which is 4 times 4. Length is 4, width is 4. So that's going to give me 16 units squared right there. So I have to add those together. 48 plus 16. So then I have, that's going to be 14, carry the 1, 64. Okay, so that's going to be 64 inches squared. So that's 64 inches squared right there. That's the answer for this one. Okay, and we're finally at 17. So the very last one, here we go. This is probably the biggest humdinger of them all. Lavita has a rectangular garden that measures 4 feet by 6 feet. Okay, this is her garden right here, 4 feet by 6 feet inside here. She wants to make a 3-foot border around her garden as shown in the diagram below. What is the area of the border? What's the area of the border? Okay, the area of the border. So I only want the border. Okay, I don't want the garden, just the border. So to me, this would be a great situation to enclose and subtract. So if I find the area, if I find the area of the whole thing right here, the length and the width, okay, like that. Then I can figure out that area and subtract out the garden part, which will leave me with only the border left, which is like the red part right here, okay? And it's only the border, which is the red part, okay? All right, okay. All right, so let's go ahead and do that. So I'm gonna erase those marks I made so that we can make it easier to see. So if I do the length times the width, so let's see if we can figure out what this is, okay? So I know from here to here is 3, and from here to here is 6. And then it also says that she wants to put a 3-foot border around it. So that means from here to here is also 3. So all the way across would be, if we mark this up, right? So if I put marks here, we know this is 3, we know this is 6, and we know this is 3. So let's add those up. 3 plus 6 plus 3 is going to be 6, 7, 8, 9, 10. It's going to be 12. So I know this whole thing is 12. Okay, the whole thing is 12 across. Now let's see if I can do the same thing and figure out what this is also 12 down here. If I can figure out what this area is, this length is. So if that length, so we know that we're trying to figure out here to here. So this would be 3. And we know that this part right here is 4, and we know this is 3. So we know we have to add 3 plus 4 plus 3. So that's going to be 4, 5, 6, 7, 8, 9, 10. So we know this is 10. Okay, so if I use length times width equals area of a rectangle, that's going to be 12 times 10 equals 120 units squared, or actually it's feet squared, I should say. Okay, so it's 120 feet squared, but I don't want the whole area. Okay, I want to get out the garden part. Okay, I want to get out the garden part, and the garden part is going to be easy because this is our length and this is our width. It's 6 times 4, which is 24. Okay, so if I do 120 and I get rid of the 24, so 120 minus 24 is 96. That's 96. So 96 feet squared. So the area of her border is going to be 96 feet squared. All right, ladies and gentlemen, I really, really want you to do well on this test. I hope you watch this video and slowly go over all of the problems. And I can't wait to see you on Monday, and I hope you have a 6-7 weekend. Bye.